Hey guys, today I'm going to teach you all about scientific notation. By the end of this lesson, you'll be able to represent very large or very small numbers using scientific notation. So go ahead and get out your binder, turn to the math section, and get ready to take some notes. So let's get started with some real world examples. So scientific notation is used to represent really big or really small numbers. We'll start with the big numbers. So before we learn what it means, let's look at just why we need it. So as you can see from these two pictures here, I'm showing you two really big things. One is the world's population. So on Earth, we have a world population of about 7.8 billion people. And in this pie chart, you can see the breakdown of population by country as of 2017. So if you thought that 7.8 billion was a big number, just imagine that just think about it. This is our planet here in the picture to the right. Our planet is here. That's Earth. So these other big planets are even bigger than what our Earth can hold. They're farther away than we can even imagine. And look how much bigger like Saturn is or Jupiter than our planet. They're so much bigger. So these are really big numbers. On the other hand, we see really small numbers in our lives too. For example, think about the size of a grain of sand, just a single grain of sand. So this person here is holding sand in their hand. This is one single grain. Just think about how small sand is or how small a dust particle would be. And then even smaller, think about cells or bacteria. These are really small numbers if we were going to represent the size of those things, especially if we were going to compare them to something else really small or something really big. So let's go ahead and get started with what scientific notation means and how we can use it to really easily represent really big or really small numbers. So today we're going to learn how to write in scientific notation. It's just a shorthand way of writing really large or really small numbers. It's called scientific notation because this is where science and math meet. Scientists, mathematicians both want to write numbers as simply and easily as possible. We really don't want to write really long, confusing numbers. So, for example, this is written in scientific notation on the top here, and we're going to learn how to do that today, but this is the small number that it represents. So we're going to learn how to write in this form today. It's really not as hard as it looks. One thing that will always be true about scientific notation is that it's always written as a product of two numbers. We're always going to have a multiplication sign between our two numbers. So just like here in this scientific notation example, we have a multiplication sign between two numbers. The first number that we write has to be between 1 and 10. So basically a single digit number. As you can see here, this first number, 4.6, is between 1 and 10. And then the second number we write will always be a power of 10. So we're going to use base 10s to write really big or really small numbers. So here we have a 10 with an exponent, and this is just the format of scientific notation. We'll always have a number between 1 and 10 times another base 10 number. So we'll worry about what we get with the exponent and where the decimal goes in just a minute, but I just want to show you that this is actually the same thing as this. This really big number is the same thing as this in scientific notation. So as numbers get really big or really small, we want to use scientific notation to represent those numbers. The first number is between 1 and 10 times a base 10 value. So let's work together to rewrite the world's population in scientific notation. This right now is written in standard form, which means it's just a regular number, and it is written to represent the number of people in the world. So we're going to rewrite this in scientific notations and maybe make it a little bit easier and a little bit less numbers. To do that, we're going to follow 4 steps. So these 4 steps here, there's only 4 steps and you can use these at any time. The first step is to create a number between 1 and 10 by moving the decimal. So step 1 is to find the decimal. I know that this is a whole number and all whole numbers have an imaginary decimal at the end of the whole number. And if I want to create a number between 1 and 10, I know that I need to get the decimal here between the 7 and the 8. 7.8 would be a number between 1 and 10. So just underneath of this big number, I write 7.8. So the first step was to just create the number between 1 and 10 and move the decimal. The second step is to count the number of times that you move the decimal. This number will be your power of 10 or your exponent on the number 10. That's what that means. So you'll always have a base 10 and an exponent. So let's start by counting the number of times we move the decimal from the end here all the way to get to that 7.8. So we went 1, 2, 3, 4, 5, 6, 7, 8, 9. So we moved that decimal 9 times, and it said in the instructions, this number is going to be our power of 10. So we're always going to have a base 10, and then you're going to have the exponent as the number of times that you move the decimal. So your exponent will be 9 here. The third instruction is if your number is greater than 1, the exponent will be positive. So I know that this number here is greater than 1, so it's going to have a positive exponent. If the number was less than 1, like a decimal, the exponent will be negative. So if it's a really, really small number, the exponent will be negative. If it's a really, really big number, the exponent's going to be positive. So if you remember, the only thing left to do with scientific notation is to write it as a product of these two numbers. So we always just put a little times between. Now you've successfully written the population of the Earth in scientific notation. Just to review that process one more time, you're always going to have a number between 1 and 10 times 10 to a power. We find this number by moving the decimal, so that way we create a number between 1 and 10, and we multiply that by the number 10 to the number of times you moved the decimal. It's a positive 9 because we moved 9 times, and it is a number greater than 1. So using those instructions, let's do some practice problems. We'll convert this number to scientific notation. If you want to try it by yourself, go ahead and pause the video and then press play when you're ready to check. Okay, so hopefully you started out at least trying the first step by yourself. The first step is to create a number between 1 and 10. So I know right now that the decimal is at the end of the number, and I need to put that decimal between the numbers to make a number between 1 and 10. It's always going to go between the first two numbers. We usually call those the significant digits, like the 1, 8, and the 5 are significant because they're not 0. And you can put the decimal between the 1 point to make it a 1.8. If you chose to put it behind the 8, you'd have 18.5. And the number has to be between 1 and 10. So my first number is 1.85. The second step is to count the number of times that I moved the decimal. So I'll count from the end, 1, 2, 3, 4, 5, 6. So that's going to be an exponent on our base 10. We're always going to have a base 10, and the exponent 6 is how many times I moved the decimal. To finish this off, I know that it's positive because this is a big number, and I'm going to have a times symbol between them. And then that's it. I've written this big number in standard form to scientific notation. So let's go ahead and try number 2 all by yourself again. This one should be a little bit easier. So pause the video, try this by yourself, and then press play when you're ready to check. Okay, so you should have just tried this by yourself. The first step is to create a number between 1 and 10. So we got to find the decimal. Right now it's at the end because it's a whole number. We want to move it to make it between 1 and 10. So we want a number between 1 and 10, so we're going to make this a 4.2. 4.2 is between 1 and 10. So 4.2 is my first number. I write that down. The second thing that I do is count the number of times that I moved the decimal to get there. So I count 1, 2, 3, 4. That number is going to be the exponent on a base 10. So 10 is the base and 4 is the exponent. It's a positive 4 because this is a big number. If it was a really small number, less than 1, it would be a negative exponent. And then I finish this problem off by writing a times symbol between it. So that's it. That's all you got to do to write this number in scientific notation. So now let's look at 2 examples of really small numbers. These are going to have negative exponents. Let's start with number 3. I'll go ahead and work with it for you, and then you're going to go ahead and do number 4 by yourself. So number 3, it says convert the number to scientific notation. We do the same steps. We want to make sure that the decimal goes between the first two significant digits. So that means that these zeros are not significant. So I start looking at the numbers, and I want to create a number between 1 and 10. So 7.826 would be my number between 1 and 10. You can't just ignore the 26. I know we've been writing with just a couple digits. We want to use all of the numbers that are there. So 7.826 has to stay. We can't drop those numbers. So you would write 7.826. We have the decimal given to us here at the beginning, and we only moved it 1, 2, 3 times. So that's going to be our exponent on a base 10. However, the rule number 3 said if your number is greater than 1, the exponent will be positive. Rule number 4 said if your number is less than 1, like a decimal, the exponent will be negative. So this is an example of a negative exponent. We use negative exponents to represent really, really small numbers. To finish this off, all you do is put a times symbol between these two numbers. Then you're done. So let's try this by yourself for number 4. You do it, pause the video, and then press play when you're ready to check. Okay, so you are finding a number between 1 and 10. I know there's only a 1 here, so I'm going to have to make 1 my only number. The decimal is here to start with, and I'm going to make a 1 my very first number. The next thing I do is figure out how many times I moved the decimal from here to get to the end. So I go 1, 2, 3, 4, 5. I moved it 5 times, and that's going to be the exponent on a base 10. It's a negative exponent because this is a decimal, really small number. The last thing I have to do to finish this problem is to put a times symbol between. So your final answer can be 1 times 10 to the negative 5th power, or you could put 1.0. It doesn't matter. Either way, this is correct. You can always check these by typing them into your calculator. Sometimes you'll get an E. So you can try it if you're on one of these like TI calculators. You might get this E in your answer. If you get an E, that just means times 10 to the power of the next number. So like this. So this is 1.26 times 10 to the power of 3. And you can see that written here too. So if you have a calculator like this and you type this in and you see an E, don't panic. It just means times 10 to the power of whatever the next number is. So the calculator is a good way to check still. So now let's do the same thing in reverse. So we've been converting numbers in standard form to scientific notation. Now we're going to be able to convert scientific notation to standard form. Here's these instructions. And we'll use number 5 as our example. So we're going to be working with this number to start with. So step 1 says move the decimal the same number of places as the exponent. It says if the exponent is positive, like this one is, we'll move the decimal to the right in order to make the number larger. So let's go ahead and do that now. We'll take the decimal in 7.83, and I'm going to go 1, 2, 3, 4, 5, 6, 7 places to the right. I stop when I count to 7. Then it says add zeros as placeholders if necessary. So all these little places between the peaks, so between the places where I put the points, I'm going to add 0 placeholders. So I'm just going to add that many zeros. It doesn't have to be cute, perfect, it just needs to be right. So I would encourage you to rewrite the number underneath of it neater. And I would say don't erase your work here. Let your work stay on your page. But for here, I'm just going to erase it just for my sake. But I would encourage you to keep it, and underneath of it, rewrite the number neater. Now we know the decimal is at the end of the number. So we don't need to write the decimal now that it's the end of a whole number. What we can do now is we can just go ahead and put those commas in. We always put commas after every 3 zeros. We start from the right to the left. After 3 zeros or 3 numbers, we put a comma. So this number would be 78,300,000. And that's it. You're done. I will go ahead and look at this next rule though. If the exponent is negative, move the decimal to the left in order to make the number smaller. So we had a positive exponent, so we moved to the right. If we have a negative exponent, like in number 7, we want to take that and move that number to the left. So let's do the same thing with number 7. I want to start by writing my number out. It's 8.345. And the exponent says negative 6. That means move this decimal to the left 6. Remember, negative, we think move to the left. So I would go 1, 2, 3, 4, 5, 6, and I would stop. This is the new place for my decimal. So in between all these little humps, I need to add zeros. So I'm going to add all zeros as placeholders. Then I'm going to erase, but I would encourage you to rewrite the number underneath of it. The decimal moved, so I can erase that decimal. You can't leave it. It has to go away because you moved it. And then I'll show all my work, but I'm going to erase it here. So that way you can see that the decimal number now is point 0.00008345. So this is a really, really small number. And be careful with your decimal, because if you even move it 1 over, it's going to change the size of this number. It'll either get really, really small or really, really big the more you move it. So I want to challenge you now to go ahead and try number 6 and number 8 by yourself, and then press play whenever you've done both of those and you're ready to check. Okay, so you should have started with number 6. It says convert this number to standard notation. Remember, standard notation just means regular number. Right now it's in scientific notation because you see a number between 1 and 10 times a base 10 value. So we'll start by writing the number 2.5, and then we move 4 to the right. The exponent tells you how many times to move. So I pick my finger at my decimal, or my pen at my decimal, and then I go 1, 2, 3, 4. And I stop and draw a decimal point at the end. In between, where there's little placeholders, I add zeros, and that tells you how many zeros to add. Once I've moved the decimal, this decimal is gone. So that decimal is gone. So I can erase that and leave that decimal at the end. Sometimes I go back and add commas after the 3 digits that are listed, so I can read this number as 25,000. Number 8 says the same thing. Convert the number to standard notation. It's written in scientific notation because you have a 9-digit times 10 to the negative 3rd power. I start by writing my 3. I know that right now the decimal is after the 3 because it's a whole number, and I need to move it 3 to the left. So I need to move it back 3. So I go 1, 2, 3, and stop and put the decimal. I want to put placeholder zeros in for any blank that I filled, and I should have this number 0.003. always want to rewrite the number because there's only one decimal in a number. There's only one decimal. So don't forget to get rid of this decimal because you moved it. So don't forget there's only one decimal and now it's here. So this is practice for you to try at the bottom by yourself, and then this will be the first thing we do in class. All right, guys, that's it. If you made it to the end of this video, please put your best friend in the comments. Today we learned about scientific notation. So now you should be able to represent very large or very small numbers using scientific notation. And then we even converted back to standard form from scientific notation. So now you should go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye.